Okay, folks, we're down to our last two topics for this unit, which the topics are going to be exponential equations and logarithmic equations. So the first part is just going to be dealing with the exponential equations, so we can just focus on that and not get too confused between the both. But what I need you to understand overall, before we get into just the exponential equations, is basically that an exponential and a log are inverses of each other. So if you have an exponential and you want to undo it, you're going to take the log. If you had a log and you want to undo it, you're going to take the exponential. So remember these properties that we had. We talked about these the very first time we talked about logs. And that was that if you had the log base a of a raised to some power, that equaled x. And same thing that if you had a raised to a power that was the log base a of something, then it was that something. And this is what those two properties look like if you were dealing with the base e. Well, basically what these are doing are taking inverses of each other. So you're taking the log of an exponential, they have the same base, they cancel each other out, you're just left with x. Here you're taking an exponential with the log as the exponent with the same base, they cancel each other out, and you're left with the x. So that idea is what we're going to be using to solve equations. Okay, so let's take a look at our exponential equations. When you're given an exponential equation, you're going to take the log of both sides, and to figure out what base to use, you're typically going to use the base that is the base of the exponential. You don't always have to. You can use the log base 10. You can do the common log on both sides. Either way, it's going to work out the same. Typically, well, every time that your base is e, you're going to take the natural log because they naturally go together. If you have a base 6, typically we're going to do a log base 6, but you could have done the common log on both sides and it'll still get you the same answer. And we'll take a look at that in a second. So first of all, let's just go to our really basic e to the x equals 7. So sorry, you're going to take the natural log of both sides because, right, what you do to one side, you got to do to the other. And this right here, the natural log and e, they cancel each other out and you're just left with x. So we end up getting x is equal to the natural log of 7. And you have a calculator that can calculate that out for you, and you would turn to that to get your answer. So that's not too hard, I think. Okay, so over here, I typically like to use the base for the log, that's the base of the exponential. So I would say the log base 6 of 6 to the x is equal to log base 6 of 21. Because now these cancel out, and I'm just left with x equal to the log base 6 of 21. Now over here, because the base is 6, we are going to use our change of base formula, which tells us we're going to do the log of 21 divided by the log of 6. And you plug all that into your calculator, you get 1.7. So had we had done the common log to both sides, we would have had log of 6 to the x equals log of 21. You would have moved this x in front, so you would have had x times the log of 6 equals the log of 21. And then to get x by itself, you would divide by log of 6. So you'd eventually get to this situation right there. I know I didn't type that out, I'm sorry. Hopefully it makes sense this way. And if not, you can play with it the other way and ask questions later. Okay, let's try some more. If you have your exponential and there's something added or multiplied to it or divided by it, you want to get it by itself, just like we do with anything. You want to isolate the term that has the variable you're solving for. So we're going to subtract 5 from both sides, and now we can take the natural log. And you don't have to write natural log on both sides. You know that when you take the natural log of e to the x, it's going to turn into x. So x is equal to the natural log of 55, which evaluates to 4.01. Okay, so this one, first thing we're going to do is we're going to divide by 4. So we get e to the 2x equals 5 over 4. When I take the natural log of both sides, it's going to cancel with the e, but I'm going to be left with a 2x instead of just x. So I get 2x equals the natural log of 5/4. I'm going to evaluate this and get a decimal and then divide by 2. So I get 2x equals 0.223, and then I divide by 2 and I get 0.11. All right, so those are all very straightforward examples. Now, sometimes you're going to get an equation that looks like this, and maybe some of you already looked at this and said, hey, that looks familiar. It should. Light bulb should be going off. This exponent is twice that exponent, so because they're in this relationship, this is a quadratic equation. It's just a different type of quadratic equation, right? So because it's quadratic in nature, we get to treat it as if it's a quadratic, and we're going to factor. So when we factor, the two factors that multiply to give me e to the 2x is going to be e to the x and e to the x. Then I'm going to look at factors of 2, which are just 1 and 2, that hopefully add or subtract to be negative 3. And so that would be negative 2 and negative 1. So now it's factored. So you remember what you do after you factor, you're going to set each parentheses equal to 0, because one of these things has to be 0 in order to multiply to get 0. So we can say e to the x minus 2 equals 0, or e to the x minus 1 equals 0. And now each of these little mini equations here we can solve. So we get e to the x is 2, and so x is the natural log of 2, or e to the x is 1, and so x is the natural log of 1. And when you evaluate, you get 0.69 or 0. And so that would be your solution. Now I do want to caution you, remember, follow the rules of your logs and exponentials. If whatever you get over here, you try to take the log of something and it's a negative, you can't take the log of a negative, so that wouldn't work. So just, keep that in the back of your mind when you are working on these equations. Okay, so we'll stop there. Hopefully that's not too much information for you, and just know that the log equations will come on another day. Alrighty, have fun with that.